Hey guys, welcome again to the Maths Club. We're going to continue our series of logarithm and we're looking at substitution in logarithm. So logarithmic substitution is a method that helps us simplify tricky maths problem involving logarithms. This approach eliminates the need to rely on external resources such as logarithm tables and allows for a more straightforward and efficient way to handle logarithmic calculations. So let's look at some examples that will bring light to what we just talked about. This first example says that given that log 2 is equal to 0.3010 and log 2 raised to the power of y is equal to 1.8062, find, correct to the nearest whole number, the value of y. So if you look at this question, we already know that from our laws of logarithm, that whenever we have log 2 raised to the power of y, we can say, so we could say log 2 to the power of y is equal to, we can bring this y down, right, and say that is equal to y log 2. Great. So if that is the case, I'll replace this one with y log 2. So if I were to be answering this question, I would say from the laws of logarithm, probably I might even quote the law and say maybe log a raised by y is equal to y log a, just to make sure that I get the full mark. So y log 2 is equal to, I'll replace it with this, I'll replace this value with y log 2, so it's equal to 1.8062. But we're told that log 2 is equal to 0.3010. So I've replaced it, so it's equal to 1.8062. If I divide both sides by 0.3010 and divide by 0.3010, so if I cancel this place and I cancel this place, if I cancel this, this 0.3, this 1.8, so it's approximately around 6, right? 6 point something something something. So really our y, and it said correct to the nearest whole number, so our y should be equal to 6, right? Because 0.3, if I have 0.3 and multiply by 6, that will give me 1.8. Our y should be equal to 6. So that is option A. Great. Now this next question says that if log 3 is equal to 0.4771, evaluate log 81 and correct to two significant figures without using logarithmic table. So we know that from the laws of logarithm that we can be able to break this log 81. How? We know that 3 raised to the power of 4, if you do it 3 times 3 times 3 times 3 raised to the power of 4 is equal to 81. So I could replace this log 81 as saying log 3 raised to the power of 4 is equal to log 81, right? And also I could just say from the laws of logarithm, right, I can bring this 4 down, so that would be 4 times log 3, right? And then we already know what log 3 is from the question. They said log 3 is 0.4771. So by the time we say 4 times what? 0.4771, we should be able to find our answer. So that is 4 times 0.4771. So this is 1.9082. But remember, they said that we should do it in two significant figures, right? So this is significant figure 1, significant figure 2. So the value after the 9 is less than 5, so it's just be 1.9. So our answer here would be 1.9. So let's see the answer to this question, and that will be option D. Now the next question is saying that given that log 2 is equal to 0.3010 and log 3 is equal to 0.4771, solve without using mathematical table the value of log 6. So let's find the value of log 6. So to find log 6, we could say from the law of logarithm, we could break this 6 into 2 and say this is log 2 times 3, right? And we could also say this is log 2 plus log 3. If you remember what we did very well in the laws of logarithm. So because of that, I can just add the values of this log 2, which is 0.3010 plus log 3 is 0.4771, right? And if you add that together, that would be 1877 7, so 0.7781. So that should be our answer. Great. So the next one is saying we should find log 5. So for log 5, we have log 2 and log 3. So what can we do? Very simple. So that will be log. What can we break apart that will give us 5? So that's like saying log 10 divided by 2. Right? So log 10 divided by 2. 10 divided by 2 will give us 5. So because the division that is joining them, I will subtract. So that will be log 10 minus log 2. Remember I said something that when the base is not given, that is a common logarithm and you take it as log base 10. So this is like saying log 2 base 10, log 10 base 10. And if you remember from the law of logarithm, we said when the base and the number are the same value, the value is equal to what? Great, is equal to 1. So this is equal to 1. Right, from the laws of logarithm. So this is equal to 1 minus, what do you say log 2 is? Log 2 is 0.3010. So if you subtract this, that is 1 minus 0.3010. And this gives us 0.699. So this is 0.699. Let's see if we're correct. Great, we're correct. So the next question is saying that we should find log 180. So for this log 180, we have log 2 and log 3. So what can we break apart in this log 180? So what if I say log 10 times 18? We could break it apart and say log 10 times 9 times 2, right? So if we have all of this in separate, we could say this is log 10 plus log 9 plus log 2. I could simplify this log 9 as saying log 10 plus log 3 squared plus log 2, right? And I could bring these two down, right, based on the laws of logarithm and say log 10 plus 2 log 3 plus log 2, right? So you can see how we've been able to break it down. Now we can now replace. We know that log 10 base 10 is 1. So this is 1 plus 2 times log 3 is what? 0.4771. So that is times 0.4771 plus our log 2 is 0.3010. Great. So now all we just need to do is just to simplify. So this is 1 plus 2 times, so 2 times 0.4771, that will give us 0.9542. So plus 0.9542 plus 0.3010. So now let's add all of these things together. So this 1 plus 0.9542 plus 0.3010. So by the time I do have 2.2552. So this is 0.2552. Great. So let's see if our answer is correct. Great. So our answer is correct. And last one is saying that we should find the cube roots of 0.03. So for this particular question, we can let's simplify 0.03. 0.03 is something as saying 3 over 100, right? Based on the way we used to convert it to say 0.03 divided by 1 first, Abi. Then we multiply it by how many zeros, how many values do we have after the dots? We have 2, so that is 10 raised to the power of 2, right? 10 raised to the power of 2 is 100. We multiply the top and bottom by that value. So this is something I've treated before. So 0.03 times 100 is 3. All over 1 times 100 is 100. So we've converted it to fraction. So if any of this is not clear, you want to check the video that will pop up at the top right. Now, when we have this, so we can put it back and say this is log cube roots of 3 over 100. Now, log cube root of 3 over 100 is something as saying log 3 over 100 raised to the power of 1 over 3. From the laws of logarithm, we could bring 1 over 3 down and say 1 over 3 log 3 over 100. Great. So I can be able to reduce this from the lowest logarithm. So this 1 over 3, open bracket. So this will be log 3 minus log 100. Right. So 1 over 3 in open bracket. Our log 3 is, I think, 0.4771. So that is 0.4771 minus our log 100 can be written as log 10 squared. So I could say this 1 over 3, 0.4771 minus, I could bring this 2 down. That's 2 log 10. I know log 10 is equal to 1, right? So this is like saying 1 over 3, 0.4771 minus 2 times 1, which is 2. So by the time we do 0.4771, I'll subtract it from 2, or subtract 2 from it. That will be minus 1.5229. So this will give us 1 over 3 times minus 1.5229. Okay. So if I divide this value by 3, so this will be minus 0.508. So minus 0.508. Great. Let's see if our answer is correct. Yeah, so minus 0.5076 or minus. So if we took it to this point, then that will be minus 0.5076. Great. Now let's look at the last question on this. So it says, given that log 5 is equal to 0.699 and log 3 is equal to 0.477, we should solve. First one is log 45. How can I be able to find log 45 in terms of 5 and 3? So I could say 45 is like saying 9 times 5, right? And 9 times 5 is like saying 3 squared times 5. So if I replace it, I could say log 45 is equal to log what? 3 squared multiplied by 5. So this is like saying log 3 squared plus log 5. Remember, whenever it's multiplication that you're joining them, you can break them apart with plus. So if I do this from the law of logarithm here, I could bring this 2 down and say this is 2 log 3 plus log 5. And if I replace what they gave me, so this 2 times the log 3 is 0.477 plus the log 5 is what? 0.699. Great. So let's use our calculator to simplify. So 2 times 0.477, 0.954. $0.699. So if we add it together, we say plus 0.699. That will give us 1.653. So this is 1.653. Let's see if our answer is correct. Great. So this is 1.653 correct. So I think the other part is saying that hence we should now solve x raised to the power of 0.8265 is equal to 45. So x raised to the power of 0.8265 is equal to 45. So we'll take the logarithm of both sides. So that will be log x raised to the power of 0.8265 is equal to log 45. Right, don't panic, it's nothing. So you can, if you have situations like this, you can take log of both sides. So from law of logarithm, I could bring this value down. That would be 0.8265 times log x is equal to log 45. Right. So we already know that log 45 is what? 1.653. So that would be 0.8265 times log x is equal to 1.653. Great. So if I divide both sides by 0.8265 and 0.8265, this will cancel this. We'll be left with only log x here. Let's see what the other part will give us. So that will be 1.653 divided by 0.8265. So this will be 2. This is 2. Right. So at the end of the day, we have log x is equal to 2. I know this log x and say log x base 10. Converting to indices. Converted to indices, right? How can we say? We say, how do we do this? Say 10 raised to the power of 2 is equal to x. So 10 raised to the power of 2 is equal to x. So 10 squared is 100. So our x is equal to what? Is equal to 100. So what did we just do? The only thing that we really just did that was a bit technical here was that we took the log of both sides. And that is very possible. Let me just do a small example. So if you know x squared is equal to 25, right? We want to find what x is. So we can find the log and say log 25 and log x squared and log 25. So I'll bring this to down. So that'll be 2 log x is equal to log 25. At 25 seems like saying 5 squared. So 2 log x is equal to log 2 log 5. I can divide both sides by 2. 2 will cancel 2. 2 will cancel 2. And we have log x is equal to log 5. So if I do a comparison of both sides, you can see that the x is what? The x is 5. So you can see this is actually a very valid method. So let's say our answer. So our answer is 100. So that is basically it about substitution in logarithm. In the next video, we're going to be looking at how to actually read the logarithm table. See you guys there.